Okay, let's start. Ratio and proportion. Let's begin with the ratio. Okay, so anybody wants to tell what is a ratio?
Ma'am, ratio is comparing two quantities.
Yes. Anyone else?
It can also be comparing more than two quantities, right now.
Can also be compared more than two quantities. Yes. Ratios can be like comparing more than two quantities as well. Okay. Now, moving on. Mostly there is a comparison between two quantities. Okay. But then, like I've seen like the ratios between
Like 2 is to
three,
3 is to 4, 3 is to 4 is to 5, like
three,
that.
yes, three quantities and four quantities as well. So now ratio. Also, we can say that ratio, it's the relation between two quantities. Okay, where one quantity, where we see that where one quantity is how much more than the other quantity. Okay, but an important part is comparison is done between, like we mostly compare the similar type of quantities. Okay.
So
It's the
should we
relation.
write this as two or more quantities, relation between two or more quantities?
Yes, you can write. Between two or more quantities. Where one quantity is how many times the other one. Okay. Now, for example, now we are going to take one example. Okay. Suppose there are 100 boys and 80 girls in a classroom. We have to find the ratios of boys to the total number of students. Boys to total students and boys to girls.
Ma'am, boys to girls is 5:4, right? 5:4.
Yes, 5:4. Okay. Now, how many are the total students? What's the number of the total students?
180.
180. Very good. So now it's saying boys to total students. Boys is how much? 100. Boys are 100 to 180. Okay. That is the total number. So it becomes 100 divided by 180.
Ma'am, 5:9.
Yes. So we cancel them. 0 with 0. 2 5s are 10. 2 9s are 18. We have the fraction 5 by 9. 5 by 9, which we will write in the form of 5:9. Okay, so the ratio of boys to total students is 5:9. Okay, now boys to girls. What's the number of boys? Again, 100. And the number of girls is 80.
Ma'am,
100,
5:4.
yes, 100 to 80. So it becomes 100 divided by 80. Now cancel. 2 5s are 10. 2 4s are 8. Ratio becomes 5:4. Okay, boys to girls. So this is all about the ratio portion. Okay, this is how we calculate the ratio. Like we divide the terms, cancel, reduce them to the lowest term possible. Okay,
Ma'am,
like until it keeps dividing, you keep on dividing, you keep on reducing. Then
ma'am,
you reduce it to the lowest 1 second, and then you will get your ratio. Yes. Now see.
ma'am.
See.
Okay, so the left number of the ratio is called antecedent and the right number of the ratio is called consequent.
Yes, that is right. Now there are two parts of this ratio. Suppose I'm having, let's pick the ratio 5:9. 5 to 9. Okay. Now this ratio, our ratio always has two parts. And all the parts of a ratio are combined. When we like combine them, each part are known as terms. Okay. But then the right part, that is 9, separately, if we call them, the right part of the ratio is known as consequent, and the left part of the ratio is known as antecedent. Okay, right part of the ratio is known as consequent, and the left part of the ratio is known as antecedent. Okay, both of them are terms. Dana, hope it's clear.
Yes, ma'am.
Okay.
Done, ma'am.
Okay. Shall I erase it? Samir?
Done, ma'am. Finish copying, ma'am.
Okay. Okay, so let's move on to the next part. The proportion part. Can anyone tell me what is a proportion?
Ma'am, the comparison of two ratios.
Ma'am, the equality of two ratios.
Yes, that's right. Both of you are correct. The comparison between two ratios or the equality of two ratios is known as proportion. Okay, so we can write down. We'll also see how proportion works, like what exactly is this equality, okay, or comparison between the ratios. The two ratios are equivalent to each other. Okay, or the relationship between two different things. Okay, now how to know that the terms are in proportion? Okay, or how do we actually find the proportion?
Ma'am,
Yes,
ma'am, the product of the first and the last term is equal to the product of the second and third term.
yes. Suppose I have this equation 3:4 equals to 45 to 60. Okay, this
Ma'am,
is a proportion equation. 1 second, Edric. Now I have to check if this is true or not, like if this is actually in proportion or not. Now, there are two things there. These two terms, okay, are known as middle terms. Middle terms, okay. And the two outer terms, these and 60, are known as extremes.
ma'am can also say that 4 and 45 are the means.
Yes, 4 and 45 are the mean terms or the middle terms, and 3 and 60 are known as extremes. Okay, now how do we know that this equation is in proportion? Okay, that all the terms in it are in proportion. So we multiply the middle terms and we multiply the extremes. Okay, if the product, if the answer of both of them are equal, then we can say that all the terms in this equation are in proportion. Okay, now multiplying the middle terms, that is 4 into 45. Okay, how much we'll get? Multiplying
Ma'am, 180.
180. Then multiply the extremes, that is the outer terms. 3
Ma'am, 3 into 60 is 180.
into 60 again is 180. Okay. So if your equation is in proportion, your product of the middle terms and the product of the extremes will be equal. Okay. Hence, 3:4 is equals to 45 to 60 is true. Hope this part is clear to you.
Yes, ma'am. Ma'am,
Zara, hope it's clear.
Yes, ma'am.
finish copying, ma'am.
Okay. All right. So now moving forward. Okay, Ajay. Now, sometimes what may happen that we are given three terms and one term we are not given it. We have to find it. Take a look at this example now. 4 is to 12. Is equals to 18 is to x. Okay. 4 is to 12 equals to 18 is to x. We have to find out the x. That's the fourth term. Like what's the value of x? So again, like the method we follow in
Excuse me, ma'am.
proportion. Yes, Sarah. Sorry, yes, Anaya.
Will the answer be 54? 18 is to 54.
Yes, answer will be 54. That's right. Okay, now what do? We multiply the middle terms together, okay, and the extremes together. Okay, so it becomes 4 into x equals to 12 into 18. Okay, 4 into x is how much? 4x equals to, multiply 12 and 18, we have 216
216.
to 16. Okay, now finding out the value of x equals to, bring to a 4 down to 16 divided by 4. So the value of x will be
54.
54. Okay. Hope this part is clear to you.
Yes, ma'am.
Everyone? Zara, Samir, clear?
Just give me a minute. I'm popping it.
Sure, sure.
Done, ma'am.
Done?
Done, ma'am.
Okay. All right. Now this question is for you all to try out. Find the mean proportion of 3 and 27.
Ma'am?
Suppose, yes,
Ma'am, 9.
the term of mean proportion Rx. First, put this in an equation form. Okay. Put this statement in the form of an equation. All right, it's telling you that the mean proportions are x. Okay, we consider them x, and that we have to find its value. Okay, so put this in an
Ma'am, become
equation.
3 is to
Yes,
x as x is to 27.
yes.
Ma'am, x equals to 9.
Yes, that's right. Okay, let's try it. The equation will be 3 is to x.
Can you do it? Can you do it as x raised to the power 2 equals to or x squared equals
Yes, Anna. Yes, Anna. It will become x raised to the power 2. Okay.
Ma'am, that's how I did it, ma'am. Finished copying, ma'am.
X into x, that's x raised to the power 2 equals to 3 into 27. X squared equals to 81. Okay. 81 is the square of 9. So x will be 9. Okay. Your value of x in this equation, both of the parts is 9. Alright. Hope this question is clear to you all.
yes, ma'am.
Yes, ma'am.
Okay. Alright. So, Ritu, any doubt till here?
No, ma'am.
No, ma'am.
Okay. Simeon done?
Yes,
Okay.
done copy.
Alright. Okay, now there are two types of proportions that we'll do now. Edric, don't tell. Do you all remember any of you?
No, ma'am.
Like what, ma'am?
Two parts of the proportion, like two types of proportions are taught. Okay, no problem. They are like the proportion is basically of two types. Okay, like two types it can happen, the proportion. Okay, one is known as direct proportion, one is known as inverse proportion. Okay, direct proportion and inverse proportion. What are both of them? We will study. Now, take a look at this example. Take a look at this example. I purchased a book. Okay, one book. One book I purchased of rupees 100. Okay, I purchased one book of rupees 100. Now, I wanted one more book. Okay, so I purchased
Two books.
one more book. Okay, so it became two books worth
Ma'am,
rupees 200. Worth rupees 200. Okay, now if we observe this, what is happening in this case? First, I purchased one book of 100, but I wanted more, so I purchased two books of 200. Okay, so quantity is increasing. Okay, price is also increasing. Okay, quantity is increasing and price is also
I
increasing
remember,
because
ma'am, you had taught us this earlier.
yes, yes. Now because quantity is increasing, price is also increasing. So this is what direct proportion is. Okay. When increase in one quantity leads to increase in other quantity. Okay. Increase in one quantity will lead to
And ma'am, inverse proportion is when one quantity is increased and the other is decreased, right?
yes.
Yes.
Next is inverse proportion. Let's take a look at another example. Suppose I am driving a car at 50 kilometer per hour. 50 kilometer per hour. Okay. So it's taking me to reach my place. It will take me 1 hour time period of 1 hour. Okay. 50 kilometer per hour. I'm driving at a speed of 50 kilometer per hour. The time it's taking me is 1 hour. Okay. If I increase the speed of my car and drive at 100 kilometer per hour.
Ma'am, it takes half an hour.
Yes, it takes half an hour. Okay. So what happens? I increase the speed, the time it was taking me will reduce. Okay, because my car is moving much faster now. Okay, because my car is moving much faster now. So the time it was taking me to reach was decreased. Okay. So the speed was increased and the time was decreased. This is known as inverse proportion. Okay, inverse proportion where where one quantity changes in relation to the other quantity the in an opposite manner. Okay, inverse means what? The reverse of something. Okay, basically the opposite of something. So when one thing is increasing, the other thing will decrease. When one thing is decreasing, the other thing will increase. Okay, this is known as inverse proportion. Increase in one quantity in one quantity will cause the other quantity to decrease or the decrease in other quantity. Okay, this is known as inverse proportion. Any doubt till here?
No, ma'am.
No, ma'am. Okay.
I
All right.
have a doubt. If
Yes,
like if
ma'am.
have a inverse proportion, can you make it a direct proportion?
Inverse proportion. Can I make it a direct proportion? The car example you were saying.
No, like in
Inverse.
any example.
Can you want any some other example of inverse proportion?
No, I meant not just in the car example. In any inverse proportion, can you make it and use it like a direct proportion? And can you do the same for a
Can you use it like a direct proportion? See, Simran, like there is some like difference in direct proportion and inverse proportion. Okay, inverse proportion you cannot make it a direct proportion because the change in quantities is happening differently in both the types of proportions. Right, in direct proportion, the quantity, both the quantities will increase if they are increasing. Okay, or if they are decreasing, both will decrease. Okay, in
Ma'am,
direct proportion because one second, Andrew, because they are in direct proportion. Okay, means impact of one thing will take place on the other quantity. Okay, the one quantity will directly impact the other quantity in the same manner. Okay, in the same manner in the direct proportion. All right, you cannot make it in the inverse. Okay, in most cases you cannot make it inverse. But in inverse proportion, opposite effects will happen. Okay, in this
ma'am,
also, one thing, one second, Edric, one thing will affect the other thing. Okay, one quantity will affect the other quantity in inverse proportion as well. But opposite impact will happen. Okay, not the similar impact, opposite impact will happen. Like increase in speed, decrease in time. Okay, increase in one quantity, decrease in the other, or the decrease in one quantity and increase in the other. Okay, same thing will not happen when it is an inverse proportion. Like because it is an inverse proportion. Okay, you cannot really make it a direct proportion. All right. Hope it's
ma'am.
clear. Okay, Edric. All right. Yes, hope it's clear to you.
Yes, ma'am.
Yeah.
Okay. Now, homework for today is revise. One second. This is page 107 to page 111. Revise till here. Okay, page 107 to 111. There are some questions related to what we studied today. Some parts where you have to try, where you have to calculate the ratio. Some parts where you have to calculate the proportion. Like proportion part is smaller. Okay, and ratio. You can like I know you all have practiced this chapter before. So what you can try out is pick out random questions. Okay, don't look at the solution. Pick out any random questions from like page 107 to 111 from the exercises or the examples and try them out by yourself. Okay, to check if you are able to do it. Okay, this is the homework for today. We will continue further with proportion in the next class. Okay. Anything else that you want to ask? Hmm. Okay. Okay then, Edric, Sarah. Bye. See you all in the
Bye,
next class.
ma'am.
Bye.
Bye, ma'am. Thank you.
Okay. Bye. All right, then I am sending a little break for you all. Okay. And then finance, and then we'll be starting with the science. Okay, hope you all are there. We are going to start with the chapter for the science class. And the presentation is a fine if it first talks about tornadoes and how they spin around.
Excuse me, ma'am.
Yes, and I am.
Are we continuing with the doubts classes or going back to the regular classes?
We'll continue with the doubts class if you have any doubts, or else we'll start the regular classes.
Yes, ma'am. I have doubts in chapter 10, the heat chapter.
Heat chapter. Okay. Yes, Simran, you can go on with the order that you have sent. Okay, it's fine with me. Like the order, you guys can put it in any order you want, but make sure to include the things that I mentioned. Okay, don't miss out on anything. The PDF about the presentation. Okay, make sure you include it all, but you can put it in the order that you find is more suitable. Okay, tenth chapter, right? Yes, ma'am. What's the doubt from the tenth chapter?
Yes, ma'am. I have doubts in the different types of thermometers, the clinical thermometer and the laboratory thermometer.
Okay, you want me to explain this part once again?
Yes, ma'am.
Okay. Now, thermometer is a small thing, a small device that's used to measure the temperature. Okay, two types of it are there: clinical thermometer and laboratory thermometer. Okay, so clinical thermometer, it measures our body temperature. Okay, it's the thermometer that measures our body temperature, and it has a narrow glass tube and a bulb at one end, which is containing the mercury. Okay, when we put it close to our body, okay, that small ball, it rises up to the temperature that our body is having. Okay, like it measures that temperature, our body temperature. Okay, if it's high, then it will go up, like really up. Okay, if it's medium, then the ball will stay somewhere in the middle. The marks are being made with which we can check like what degree fever we are having. Okay. Then it has a kink near the bulb which prevents the mercury ball from falling on its own when the thermometer is taken out of mouth and we can read it. Okay. And there is a scale in the thermometer with which we can measure the actual temperature. Okay, we use the Celsius scale indicated by degrees C. Okay, and the clinical thermometer reads temperature from 35 degrees Celsius to 42 degrees Celsius. Okay, and some thermometers have the Fahrenheit scale, that is degree F. Okay, and Fahrenheit scale reads from 94 degrees Fahrenheit to 108 degrees Fahrenheit. Okay, so Now, the normal temperature of a healthy person is 37 degrees C or 98.6 degrees Fahrenheit. Okay, like after exceeding 98.6 degree F, your body temperature will be higher, like the fever will be there. Ever heard 100 डिग्री का बुखार है, 100
हाँ,
डिग्री से 104 डिग्री बुखार, right? So that is when the 98.6 degree Fahrenheit temperature is exceeded. Okay, they say that 100 degree fever, 104 degree fever. Okay,
I
that's when
think
it
even in India they use less of the Celsius scale and more of the Fahrenheit scale only
Fahrenheit scale. Yes, more
for
of the Fahrenheit.
thermometer.
Yes, that's right. Here we use more of the Fahrenheit scale, but yeah, Celsius scale is also used at some places. Right. Then, the reading is taken. We know how to use the thermometer. Like, we wash it properly to with an antiseptic solution, and then we hold it and give it a few jerks so that the mercury can be positioned. Okay. Um, then it will bring the level of mercury down so that it can start from the initial level, like from the beginning point, it can start the temperature when you will measure it. Okay, then we check that it falls below 35 degrees Celsius. Then we place the bulb under the tongue. After 1 minute, we take it out and note the position of the mercury on the scale, okay, to get the temperature of our body. Then we are having a laboratory thermometer. This is used to measure other objects, okay, the heat or the temperature of the other object. Now, a laboratory thermometer has is made up of glass again. Okay, it looks like a long, narrow glass tube. The lower end of this tube is like a bulb. This tube contains mercury or alcohol. Its upper end is sealed. Okay, the glass tube is kept in ice cubes. The point in the tube where mercury becomes steady after getting cooled is marked as 0 degree. Okay, like where the mercury becomes steady. Okay, and it's like stored with ice cube. It's stored in relatively cold temperature. Okay, and then it's kept in the stream of boiling water. So the mercury will start to expand. After cooling, it will be heated up. So the mercury will expand. Okay, and then after the heating up process is done, the mercury becomes steady, and that point is marked as 100 degrees Celsius. The intervening space between 2 points is divided into 100 equal parts. Okay, not really 100, but yes, we can say that they are marked denoted as 100 parts in between each segment. The intervening, thus the measure of each small division is 1 degree Celsius. Generally, the range of this thermometer is minus 10 degrees Celsius to 110 degrees Celsius. Okay, this is used to measure heat from various other substances, can be liquids, okay, can be some chemicals or things like that. Okay, it's like glass tube, like I've seen this thermometer, it's like a thin glass tube, thin and long glass tube. Is there never really used this one? Okay, clinical I've used, but a laboratory thermometer I haven't used. But yes, it's used to measure other things. Okay, other chemicals or the temperature of other objects. All right, so there are some precautions. Okay, like the bulb should not touch the walls of the container. It should be kept upright in a standing position while using it and all. Okay, hope it's clear now. A laboratory thermometer and a kind of clinical thermometer.
Yes, ma'am.
Okay. After the class, you can go to YouTube and watch how a laboratory thermometer is used. Okay, you can watch how they are using it. Okay, to measure the temperature of different things. Right. So, moving on. Anything else from this chapter? Any other
Yes,
doubt?
ma'am. Propagation of heat also I had doubts in. I didn't understand exactly how The process of transfer displacement of heat is taking place.
Yes. Now, propagation of heat is basically the moving of the heat from one place to the another. Okay, from one body to the other. That is basically the propagation of heat. Now, what happens? Like they have given an example. See, we have a metallic rod, okay, which is heated from one end, okay, which is heated from one end. So from this end, it will become hot, okay. From this end, it will become hot, and then slowly, what will start happening? It will start becoming hot from this end as well, okay. It will start becoming hot from the other end as well. Why? What's happening? We are not heating the other end. We are only heating one end. But still it will start getting warmed up from the other end as well, from the mid and from the towards the other end. Why? Because the heat is traveling to the other end. Okay? Because the heat is traveling to the other end.
Through
So
molecules, ma'am.
yes, the molecules or the energy basically, okay, is traveling from this side to the other end of the rod. Now, this action shows that the heat flows from one object to another, from one place to another, okay, or one part of the object to the other part. The process of transfer or displacement of heat, okay, this is known as propagation. Like the moving of the heat, the energy, the heat energy from one part or the another, or from one object to the other, is known as propagation of heat. Okay, so hope it's clear to you now.
Yes, ma'am.
How this is basically the propagation, the traveling of heat,
Yes.
okay, from one body to another. Anything else?
No, ma'am, that's it.
That's it. Okay. So we'll begin with our chapter. We finished with the natural calamities and disaster management chapter, and we'll start with the natural resources chapter today. Okay, now natural resources. There are two chapters of natural resources. Okay, why? Because all the natural resources are divided into two parts. Natural resources are divided into two parts. That is physical resources and biological resources. Physical resources and biological resources. Okay, so this chapter, the 19th chapter, we are going to talk about physical resources. Okay, it's about the
What's
first
the
part.
difference between physical and biological?
What's the difference between physical and biological? See, both physical and biological are natural resources. What is the difference? Biological resources are the living resources, okay, like humans, birds, trees, and all. They are biological resources, whereas physical resources are air, water, sand, etc. Okay, that is the main difference. Biological, okay, are the more of the living resources, the plants, the birds, animals, mammals, all of that, okay, comes under biological resources. But they are also a part of natural resources. Whereas physical resources, we have mostly the non-living things, that is air, water, soil, and all that. Okay. But again, this is also these are also natural resources. So both physical and biological are natural resources. Okay. Now, what are natural resources again? Resources that we have in nature. Okay. Like the resources of nature, or the things nature is made up of, or the resources that we have which are of the nature are the natural resources. Naturally made. Okay. You can say are all the natural resources. Now, we see many things around us, like plants, animals, birds, trees, mountains, soils, rivers, ponds, runnels or channels, sun, moon, and many other objects. All these items are received by nature. They are all part of nature. So they are known as natural resources. Now, these are all of two types. One, which have life, like humans, animals, birds, etc. Secondly, non-living things which do not have life, like air, water, soil, food, etc. So the living things, things which have life, are known as biological resources. And things which do not have life are known as physical resources. Okay. So this chapter is about the physical resources. That is the things which do not have life. All right. Now, our nature has two types of resources: physical resources like air, water, soil, sun, wood, mountain, etc. Biological resources like humans, birds, animals, insects, microorganisms, plants, trees, etc. Both are together called natural resources. These are useful to us in one form or the other. Right, like air and water are required for life. Plants and trees for making food, sun for light and energy, birds and animals, sun for light and energy. Birds, animals, and other organisms are useful in production of food. So, in this way, other organisms and physical objects are needed for many important things. Right, we know that all of these natural resources, okay, both of the natural resources, like the biological resources and the physical resources, are important for us to live. Okay, in our day-to-day lives, both help us, both sustain our living. Now, because we are studying the physical resources, the first resource we have is air. Okay, it's an important physical resource. It's an important resource for us to do a lot of things. Right. Now, although we cannot see air, but it surrounds us, it's present everywhere. Okay, can you tell me any two uses of air? Why air is such an important source for us, such an important natural resource? Why?
Because we need to breathe, it provides the oxygen which we need to breathe.
Yes, very good. Anything else from you? Okay.
Now, air also contains
Yes. Say one by one. Say. Anaya, you say first.
Okay. Air also contains the atmosphere we need. So now it doesn't just contain oxygen, it also contains other gases such as nitrogen, what is the other carbon dioxide side because and yeah. Well,
Okay. Yes, good. Yes, Ayman, you were saying. You were saying something, Samir?
What did you say?
What did I say? I said that, were you saying something like giving an example of why air is important?
For us to breathe.
for us to breathe. Okay. Yes. Air is a mixture of a lot of other gases such as oxygen, carbon dioxide, nitrogen, okay, which again has a lot of functions, okay, like oxygen helps us to breathe, carbon dioxide helps the plants to respire, right? Nitrogen helps to balance the atmosphere, balance all the gases and the amount of all the gases in the atmosphere. We talked about nitrogen cycle, right? So all these gases they are there in the air. The air comprises of all of them. And to do that, air is important for us. Now, we are going to talk about the elements of air. Like we just talked, that air is a mixture of many gases. But the main gases in the air are oxygen, nitrogen, and carbon dioxide. These are the main gases, the main elements of air. Other than these, air has what else do air has? Air has a lot of other things too, like water vapor, dust particles, smoke, and other gases. Okay, now oxygen present in the air is a life-sustaining gas. Animals or the organisms living in water also use oxygen for breathing. All organisms and plants use oxygen present in air for breathing and leave carbon dioxide. So carbon dioxide should be the largest air, but largest gas in air, but it is not so. Why? Because plants use carbon dioxide from air and water and minerals from land in the presence of sunlight to prepare food. This process is known as photosynthesis. This process releases oxygen, which mixes in the air. We know that plants use carbon dioxide to prepare food and then gives out oxygen. This we know, right? Which again balances the amount of oxygen and CO2 in the air. And what we do, we take in oxygen, release the CO2. Have you heard this that we should plant more and more trees so that it will reduce the pollution, so that it will be more helpful for the environment? Right. Another reason they say this, like they suggest to plant more trees, is because the plants will give out the oxygen, right? Plants will give out the oxygen, which again helps for us to breathe. It balances the amount of the gases in the atmosphere. Now, this is a pie chart showing the composition of the various gases in the atmosphere, okay, or in the air. Now, 78% nitrogen gas we are having, 21% oxygen, and carbon dioxide or other air 1%. Okay, that is very less quantity of CO2 we have in the air. Okay, someone around 1/4 of the oxygen we have near about, and the rest of it we have the nitrogen gas. Due to this activity by plants, gas balance is maintained in the air, like I just explained, that we release CO2, we take in O2. Plants take in CO2 and release O2. So this thing creates a balance in the air. So we should plant more trees to keep oxygen in required quantity. Alright, 9.1 is the homework for you all. Try this out. Okay, now utility of oxygen and carbon dioxide present in the air. What's the importance of this oxygen and CO2 present? Now, you must have seen igniting a stove or when coals are burnt in iron. When air is blown or fan is used, wood and coal starts burning fast. This happens because oxygen present in air helps helps in the burning of fuel. The more the oxygen is supplied, the more fast the fuel gets burned. Other gases present in the air, like CO2 or other gases, do not help in burning, but they extinguish the fire. Okay. So oxygen is the gas that helps the fire to burn. Like in the old times, they had this stove called as chula. They other women when they used to light the fire, they used to blow in it with a pipe. Okay, they used to blow in it with a pipe, the air, so that the fire
Grandmother still
ignites.
does that.
Your grandmother still does that? Yes. So they do that because to ignite the fire faster and a good flame, to ignite a good flame. Okay, they supply the air in the fire. Okay. Now, oxygen is that gas which helps in burning the fire, okay, which like supports the ignition of a fire, the igniting of a fire. Now, this is an activity, you can read it. Fire extinguishers, they like we know that they supply the CO2, the carbon dioxide, to extinguish the fire, right? The other gases like oxygen we use to ignite the fire, but CO2 is used to extinguish the fire. Okay, with the fire extinguishers, whenever a fire starts, then the handle is pressed or placed upside down on floor. This breaks the bottom of acid inside the fire extinguishers. This activity releases carbon dioxide by baking powder. This air blows out the fire. Okay, think if there was only oxygen there, what would happen? This would burn the fuel, but to stop it would have been impossible. Okay, because carbon dioxide stops our fire. Okay, all right. Now, next we are having air pollution. What is air pollution? What do you all understand by air pollution? Anyone in your own words?
Making the air unfit to breathe.
Can you repeat that?
Making the air unfit to breathe.
Yes, that is right. Making the air polluted. Okay, that is air pollution. Right. Now, what happens? Air gets polluted with a lot of things. Sometimes with the smoke that is released by factories or diesel pumps, or the smoke that's released by the bursting crackers, okay, or the smoke released by vehicles such as car, bus, truck, okay, all of that contaminates the air, okay, or pollutes the air because a lot of harmful gases, a lot of harmful particles are released in the air, okay, directly into the atmosphere, which increases the concentration of those harmful gases in the atmosphere, hence polluting it. Okay, because a lot of harmful gases are released in the factories. Okay, which then they release through chimneys indirectly in the atmosphere, right? Which causes this pollution. Now, what happens now when the air is polluted? There are a lot of harmful effects of the polluted air. One is that we are um, unable to breathe properly, right? In the cities such as Delhi, okay, where the pollution is highest, right? If we talk about India, the highest pollution, highest air pollution is in Delhi. Okay, what happens there? People, a lot of people have breathing issues, right? A lot of people are having breathing issues. Why? Again, because the air is polluted. So it causes breathing problems. It leads to a lot of diseases, okay, asthma and other diseases. Okay, now again, there is also a thing called chlorofluorocarbon, which is used in ACs and refrigerators and fragrance sprays. They pollute the air. Due to these reasons, the quantity of CO2 and carbon monoxide increases in air. This further increases the temperature of the earth. Okay, this on a whole causes the temperature of the earth to rise. Okay, the this thing, the quantity of the carbon monoxide and CO2, when it increases, the composition of it, when it increases in the air, it also affects the temperature of our Earth. It's also affecting the temperature of our Earth. Okay, it increases it, and if it keeps on increasing, if it keeps on rising, it may be difficult for us in the future. Okay, the Earth, the temperature and all the atmosphere, it starts heating up due to these gases. Okay, so now it is difficult to bring back the lost imbalance of gases present in the air. So again, it gets very hard to again balance it in the same way, to balance it in a better way. It gets hard, like after so many pollution is taking place, and the tree plantation is relatively very lesser, okay, compared to the pollution that's taking place. Right. So it gets hard to again create that balance of the gases in the atmosphere. So it is better that we take precautions, that we do not pollute the air. There are some ways by which we can control the pollution, okay, by which we can control the pollution by planting more trees. Okay, like I said, that planting more trees creates a balance of O2 and CO2 in the atmosphere. Okay, because the plants also purifies the air around us, okay, um, in the environment. Then by using low polluting fuel like CNG, okay, like a low polluting fuel can be used to reduce the pollution. Pollution check of the vehicles can be done, okay. Then by establishing factories far from city and residential areas. Right nowadays, they prepare a separate, like I've talked about this before, they prepare a separate region known as industrial region, okay, that is on the outskirts of our cities, okay, where the industries are located, so that the city can be kept from all the air pollution, the noise pollution, and everything, okay. Then we have by using filter in chimney in factories, okay, by using filters in chimneys at the factories, by minimum spray of insecticides. Some insecticides also cause the air pollution. Why? Because again, harmful gases are released to kill the insects. Okay. See, insecticides are used on way higher levels. Like suppose some big farms are there, what they do, they use helicopters. From those helicopters, they spray down the insecticides on the whole fields. Okay, they fly the helicopters and things over the fields, and then they spray all the insecticides. That is like really harmful for the environment because chemical insecticides are made up of various harmful gases to kill the insects, right? So that is also harmful for the environment. We should use it lesser than by using fragrance spray as per requirement. Some sprays some some sprays are there which contain such gases. They are made up of some gases which are harmful for the environment. Okay, which are harmful for the environment. Some sprays are contain such gases. Okay, then they have using chlorofluorocarbon cautiously in air conditioners and refrigerators. Okay, by using chlorofluorocarbon cautiously in conditioners, and refrigerators. So these are some precautions, some steps that should be taken that we can take to control the air pollution. Okay, if we do not stop the air pollution now, then in future our coming generations will have to face its consequences, its bad effects. So we should be alert and plant more trees and also take the other measures to stop air pollution, to control air pollution. Okay. Any doubts still here? No?
No.
Okay. Anaya? Okay. 9.2 is also your homework. Please try out the true or false, okay? Then we will continue from tomorrow. We will start with another physical resource, that is water. Okay. So I'll meet you guys tomorrow. See you all then. Have a good day. Bye.
Excuse me, ma'am, I just have a question.
Yes, ma'am.
For the case study presentation, ma'am, it will be on Friday morning only, right? Science class timing. Or
Friday
will it be
morning.
Friday afternoon?
Friday afternoon I won't be able to take. Okay. And the Friday, this Friday is it 15th? No, it's not 15th. 15th is next Friday. Okay. So this Friday morning itself it will be there. Okay.
Morning, okay. Will there be maths class on Friday?
Will there be math class? I'll let you know.
Okay.
Okay. Okay. Okay then. See you.